Hi. So this is the first video that I'm uploading. This is on module 2. Module 2 has two parts. The first part is radar equation and the second part is radar cross-section of targets. Now, before that, today is the deadline for assignments 1 and 2. So I hope you are uploading it in Google Classroom. Now, let us start with module 2. Module 1 and module 3 were already done in classes, and the notes are shared with you already. There are two topics pending in module 3, that is clutter attenuation and MDI improvement factor. I am planning to take that in the online live classes with Zoom. Now let us start with module 2. Let's go through the syllabus first of all. This is the syllabus of module 2. The first topic is prediction of range performance. So in this video, we'll be doing that topic. And then in the coming days, I'll upload the video of the other topics. Now let us start with the first topic, prediction of range performance. Now, these are the radar range equations which we have already handled in module 1. This simple form of radar equation was finding the expression for received power using the transmitter power, transmitter radar gain, the radar cross-section sigma, and the effective aperture AE. R is the range from the radar till the target. Now, when the range is maximum, the received power becomes S-min, as we have seen in module 1. The other two forms of radar range equation are these. These two forms of radar equation is obtained when you substitute G is equal to 4 pi A by lambda square in this equation. So these were the three forms of radar range equation. Now this range equation focuses on R max. But now the problem with this range equation is the receiver noise, which we were not considering in module 1. In practice, these equations do not actually predict the range performance, though they are actually supposed to do it. Now with this equation, that is the R max equation, the actual range might only be half predicted. That is because of several reasons. They are, the first reason for the uncertainty is that S-min, that is the minimum detectable signal, is influenced by noise, that is the receiver noise, and is statically determined. The statical nature of minimum detectable signal, that is the first issue. What do you mean by statical nature? Statical nature means we have heavy amount of data which actually gives you the prediction. We all know that in the radar range radar block diagram, which we have seen in module 1, the last block would be the prediction, that is the decision, target decision. So this was based on the threshold which we keep. So all these are actually probabilistic. Now the statical nature of received noise and the target cross-section requires that the maximum radar range be described probabilistically rather than by a single number. So this S-min is actually determined in a probabilistic manner. So the statical nature means that we need heavy data and heavy amount of predictions in order to give the actual target detection. Now, the second problem is the radar cross-section fluctuates randomly. The fluctuations and uncertainty in radar cross-section targets radar cross-section, that is sigma. That is the second issue. The third issue is the losses which a radar system experiences. There is a topic called system losses in this module, which we'll be handling in detail at the end of this module. But as of now, let us keep it general that the losses in the receiver system, which were actually ignored in the radar range derivation. So these losses also contribute to uncertainties in the range equation. The fourth issue is propagation effects, which is caused by Earth's surface as well as the atmosphere. Now, so these are the issues. These four issues account for the failure of simple form of radar equation. Now, the specification of range must thus include two things. One is The radar will detect a specified target at a particular range and with a specified probability of making a false detection when no target echo is present. So basically range of radar will be a function of two things. So this is important. So if you go through this, due to the statistical nature of variables in the radar equation, which we saw in the previous slide, this radar range equation, that is the performance of radar, is based on two factors, which we just said. So these two are the probability of detection, that is PD, and the probability of false alarm, that is PFA. So we know what are these two things. We have gone through these in module 1. Probability of detection, that is a probability that a target will be detected if it is actually present. That is a valid detection. Probability of false alarm is the probability that the target will be detected when it is actually not present. That means when the threshold is too low and a noise could be mistook for a the target could be mistook for a noise. Now, the factors affecting the radar range could be predicted with high accuracy, but problem is the statistical nature of radar detection and the fluctuations of sigma, that is a radar cross section. Now, in spite of all these, the radar equation is still an important tool in mainly three things. One is to access the performance of radar. So the radar performances can be actually verified and studied in detail using this radar equation. The second point is to determine the trade-offs that must be considered when we design a new radar system. So when we design a new radar system, there would be many compromises that has to be done. So using this radar range equation, we can understand the trade-offs that must be considered. The third point is aiding in generating technical requirements for a new radar procurement. So when we have to actually make a radar receiver and a transmitter, basically radar receiver, this radar range equation will be very useful. The next topic is minimum detectable signal, which we have gone through in module 1. So I'll not go into this in detail. You can refer to the class module 1 notes and the PPTs for this. Thank you. Now the next topic is receiver noise and SNR. I'll be making a separate video for that topic. So just go through the current topic and then let me know if there are any doubts. Thank you.